And so here we prove by induction that 2 to the power of 1 upon 2 to the n is irrational for all n greater than or equal to 1. We establish the base case. We are required to prove that 2 to the power of a half is not a member of the rational numbers. We let p, q be integers such that p upon q equals root 2, and the greatest common divisor of p and q equals 1, so that root 2 will equal p upon q, so that root 2 multiplied by q will be equal to p, and so 2q squared will equal p squared. And we recall that q and p, and therefore q squared and p squared are relatively prime. So this proves that p is even. And so we let r and s also be integers. So if p is even, q must be odd, because they have no greater divisor than 1. And so if q is 2r plus 1 and p is 2s, we have this statement here. And so 2 lots of 2r plus 1 squared is equal to 4s squared. Divide both sides by 2, 2r plus 1 squared equals 2s squared. So the left-hand side is 4r squared plus 4r plus 1, which is 2 lots of 2r squared plus 2r plus 1, and that is supposed to be equal, excuse me, I made a mistake. And that is supposed to be equal to 2s squared, but this implies that an odd number shall be equal to an even number, and so we have a contradiction, and so we have proved by contradiction that the square root of 2 is irrational. So we have the base case. 2 to the power of 1 upon 2 to the power of 1 is not a member of the rational numbers. But before we proceed with the induction, we have to establish a particular lemma. The square root of any irrational number is irrational. So, if we take a rational number and square it, where p and q are integers, we get another rational number. You can't get an irrational number by squaring a rational number. So if an irrational number has a square root, then that square root must be irrational. We've established the base case that 2 to the power of a half is not rational. We now state the induction hypothesis. that 2 to the power of 1 upon 2 to the k is irrational for all k, beg your pardon, for all n less than or equal to some integer k. And we now have to take the induction step. The induction step. We take 2 to the power of 1 upon 2 to the k, and we raise it to the power of a half. And that gets us 2 to the power of 1 over 2 to the k plus 1. But that must be irrational, because by the induction hypothesis, this number is irrational, and we have just taken the square root of it. And so by our lemma, that must itself be irrational, and so hence, by induction, 2 to the power of 1 upon 2 to the n is not a member of the rational numbers, because 2 to the power of a half is not a member of the rational numbers, and 2 to the power of 1 over 2 to the k is a member, is irrational, has been shown to imply that 2 to the 1 upon 2 to the k plus 1 is irrational, and so 2 to the power of 1 upon 2 to the n is not a member of the rational numbers for all n which are members of the natural numbers, assuming the natural numbers to be the positive integers.